Welcome back. Today, we are going to talk about curves. Curves are objects that, unlike meshes, are created within Blender using mathematical functions. This means that although, when we go to manipulate these objects, we will always see individual elements such as vertices and edges, they will be distributed along a path following a function calculation. To better realize how this concept works, let's go together to see the difference between a mesh and a curve. We select everything and delete the objects that are present by default in the 3D viewport. Then we get into the top view by pressing the 7 key on the numeric keypad, and with Shift plus A, we go to insert a circle type mesh. We set a number of 16 vertices, then enter edit mode. We see exactly what we entered, which is 16 vertices connected by as many edges distributed on a circumference. Let's make sure it's all selected, so right-click to bring up the subdivide command. Subdivide takes each selected element and divides it. We can indicate how many subdivisions to apply for each edge. By default, it is set to 1, and then we see that for each edge a vertex has been inserted. If instead of 1 we set 2, we see that for each edge, 2 vertices are inserted, and so on. What I will point out, however, is that the shape of this circumference is still that of a polygon, that is, a geometric figure with 16 faces and not a true circumference. Let's now move this object, set it aside, and go and insert a new object. With Shift plus H, we go instead to insert a curve always of circular type. In appearance, the object is identical to any mesh, and if we zoom in anyway, we see that it is always a series of edges, one consecutive to the other. Yes, a little more dense, but we are still talking about a polygon. Let's go into edit mode and see what is inside a curve. We press the tabulator key, and then we see that here we no longer have a number of vertices, but we have 4 control points that allow us to go and deform our geometry. I invite you, of course, to do some testing. For example, by selecting a vertex and moving it with the G key, we can go and change the shape of our curve. Do some experiments freely. A curve can be converted to a mesh by right-clicking and then selecting the Convert to Mesh menu. Let's do it together. Now, if we go into edit mode, we no longer have the 4 control points, but we have a mesh consisting of 48 vertices and 48 edges. Again, by right-clicking, we can perform a subdivision, and even if we increase the number of cuts, still these will always be distributed along edges. So these vertices, for example, you see are perfectly aligned because Blender took an edge and simply subdivided it. Let's go back for a moment to inserting a curve with a circular shape. What we can go and do before we actually convert it to a mesh is to go inside the properties, specifically to the data section where there is the green icon. You see that when we select a mesh, this icon is triangular shaped. We see 3 small vertices connected by 3 edges. Whereas if we select a curve type object, this icon changes shape, just to alert us that we are going to vary the information of a different object. Let's go inside this section, and we see that we have the ability to change the resolution parameter. Let's try for a moment to zoom in on a part of this circumference, and let's go and see what happens by changing the resolution. If, for example, instead of 12 we put a much lower value, such as 4, we see that we find a real polygon consisting of 16 sides, but going to increase this value, the subdivisions of these sides always go to follow a perfect curve, so we can increase the resolution of this circumference and always have the points distributed correctly by a mathematical function. It is true that we always have a polygon, but this polygon can be made denser, richer in details, and these details always go to follow the trend of a curve that is an expression of a mathematical function. Let's give it a try now by fitting another type of curve, a Bezier curve. Again, we have resolution which we can increase or decrease, and we see that all the elements that make up this curve continue to follow the shape. The advantages of this tool are considerable. For example, it allows us to use a few control elements to go and make well-defined shapes that can then be used to make much more complex geometries. Let us now see how to use a curve to make an object, such as a vase. For this example, I will use this image that you can safely download as well via the link I will leave in the description. Let's right-click and save the image as a download. Let's go back into Blender. Let's start with a new file from which we're going to delete all the objects. So let's go in and insert the image so that we can recalculate it, and we'll recalculate it precisely using a curve type object. Let's put in the front view with the 1 key on the keypad, then with Shift+, we are going to call up image reference. This type of image is just used by Blender to give us the ability to use a reference to, for example, trace a shape. Let's do this together, so let's go and select the image we just downloaded from the internet. Of course, you can use any picture of your own. You can take a picture of any object possibly to be traced. Once the image is entered, we can select it, and we can see that here on the right side, the icon has changed one more time. It is no longer green, but it is red. If we go into the data section, we can see that we have the possibility to change some things. For example, the position. By means of the offset Y value, we click and drag until the bottom of the jar matches the 3D cursor, which is currently in the center of the axis. This is convenient for us because the image is perfectly centered. If the vase were not exactly in the center of the scene, we would also have to act on the offset X value to go and center it horizontally. Another thing we can do is to make the image more transparent. So we enable the opacity option, and instead of 1, we enter, for example, 0.5 or even less. Then we're going to enter the Bezier curve, Shift, plus A. Let's go to the curve section and enter Bezier curve. In the options we have here in the lower left corner, let's go tell Blender that we want to rotate along the x-axis the curve 90 degrees so that we can see it frontally. Let's then go into edit mode and go and move the control points around so that we're going to follow the trend of the vase. I realize now that actually the image is not exactly centered, so I move it slightly along the x-axis to make it match. We see it here, particularly from the neck. Well, let's go back into the Bezier curve. Let's go into edit mode and start making shifts. At first, this type of curve seems unmanageable. This has nothing to do with Blender here. In any software, Bezier curves are handled this way. There are control points that can be rotated and scaled. We start from the right point with the G key, move it around and put it momentarily here at the maximum point of the pot curve. Then we rotate the control point so that it is tangent to the curve. In short, we put it basically vertical, so instead we select the first control point and we're going to move it to the beginning of the curve, and again we're going to rotate it so that this control point is tangent to the curve. We see that the curve is not actually following the trend of our pot, but we can adjust it by using the S key to apply scale. So we put the mouse cursor a little away from the control point, then press the S key and move closer so that we scale the control point. You see that as we reduce the scale, our curve begins to approach the side of our pot. Here we obviously have to go a bit by trial and error. Let's go to select the second control point and scale it again. So here we have adhered the curve to our vessel. To continue, we need to add an additional control point. To do this is very simple. We select the second point and press the E key to extrude the curve, and we move with the mouse pointer to the next point on the curve, which could be here where the change of direction is. We then rotate again, making sure that the control point line is tangent to the pot curve. We again apply a scale, then S, and go to tighten the control point. We see that in this case it is not enough to simply scale it. We could scale the second one, but if we do that we are going to change the trend of the first part of the curve. What we can therefore do is to act on the top point. We select it, and with the G key we move it downward. In order not to risk making a rotation as well, we press Zaco to bind along the vertical, then descend until our curve fits perfectly. We see that, as I also told you before, you always have to go a little bit by trial and error. So now I'm going to match the bottom of the curve and go to reselect the next control point to apply a scale again with the S key. Let's continue. With the E key, we're going to make a new extrusion, and then, just as we've already done for all the other points on the jar, we're going to scale the whole side up to the top brim. Take, of course, as much time as you need to experiment. The commands to use are always E to extrude, C to scale, R to rotate, and G to move. Now this vase was not photographed exactly from the front, so tracing the top rim will be a bit of an eyeball thing. If you decide to take a picture yourself, try to stand as parallel as possible to the side of the vase, or even better, you could draw your template so that you can trace just a perfectly orthogonal pattern. When we find ourselves having to make curves a little tighter, we have the opportunity to take advantage of a very interesting option. If we select the center control point and right-click, we have the option of setting the type of control point with the Set Handle Type menu. If we click on Free, we see that we have the ability to move the control points independently. This is very useful, especially when we are in these situations. Let's continue now by imagining what the inside of the pot might look like. We will basically have to follow the outside pattern. However, consider that when we render, we will hardly go to see what is inside. It will be convenient for us to have a complete figure anyway, though. We also conclude the base. Again, we will benefit from having a handle type of free type. Here now, let's not worry about making a perfectly horizontal line, because we will see later how to go about precisely applying an alignment of the individual vertices.